Hi everybody. Yes, some of my subscribers wanted to see how this backup system works, and yes, how this inverter power up some of the parts of the room and stuff like that. Here in front of the camera I have the UPS or inverter controller, which makes the inverter to a UPS. We have power in, which is that mark there. We have power in, that's a 12 volt. That's this one have a RCD inside it, and that is that the RCD is okay. That we have power in 12 volts, that we have a 240 volt in, and that one which is off right now is when the power is, we have a power cut and the inverter are giving that one 240 volts, and that one gives the control contactor. I call this a control contactor, 240 volts from the batteries, and this also gets 240 volts from the main input. Main input RCD is connected to that socket. Yes, a 1000 watt inverter. We have another 300 watt inverter up there. We have a completely damaged UPS, which now works as an inverter. That powers this socket up, and I want to solder something inside here, and I don't have any wires which I can connect the solder iron to, so I directly connect it to that socket and turn this on. Of course it's off now. I have all the 12 volts off. That's actually off this for one battery, and that one is on for another battery. Two batteries in parallel. So screw it in. Of course the inverter came on. And I turn on this. As you can see, it's lights green, which means that I'm giving out 240 volts. Yes. Shut it down. That inverter have a delay. There's a RC circuit and a relay and transistor and lots of other resistors and bits like that to control it. That's connected to the switch. That switch. It's actually two switches in series. Yes, that one's on. I'm gonna screw in the other battery as well. That one is screwed in. Now that one gets power, and this inverter is not actually powering up anything. Just power off that contactor, which works as a delay, and that's it. And the wires goes down here. Nothing connected to them. But I want to connect a socket on that little box or something. My English is not the best. The white thing there. I'm gonna have a socket on the side, some backup power. And that's one of the batteries. And let's have a look down here. There's two relays. Bit dark. Shut the door so it'll be a bit brighter. Yes, there's two relays. The main contactor, and behind the main, or at the side of the main contactor, there's the Variac contactor, and there we have the Variac MCB, 10 amp MCB. I don't want it to have any more than 10 amps. The wiring can take it. 99% of all the wires which I use to power stuff up is 1.5 mil. So I can handle 10 amps. Maybe a bit more, but it's getting warm and I don't want any burn damage. Yes, these two batteries are backup batteries for the relays. And of course all the room doesn't get any backup power, just the computer, a auxiliary socket down there. The other socket doesn't get any backup power. Yes, the computer is connected to the sensitive side, which is come directly after this control contactor. And yes, this rail is for loads without backup power. So this rail will not get any backup power when I have a power cut. And this other rail, that one, will get backup power. They have their own relays. It's in that box. Let's find the box. This is hanging. 3 relays in there. And yes, these things on this rail have relays as well. And there's the wires for relay. They have big relay box under the bed. I don't know if you can see it, but it's behind the battery. No, you can't see it. Yes, but this wire is actually going to that relay box. There's 11 relays in it, I think it's 11 relays. I just use... Yes, I think I use all of them. Here's the switches. All the switches go to that relay box. That switch is for the main contactor. That one's for variac. And these 3 are for the backup rail, which gets actually backup power. That's one which was there. So these switches goes to the relays, which gives out the backup power or main grid power. It changes. It all depends how the contactor is. Yeah, control contactor. Yes, now that light must go on. Of course it didn't, because I didn't screw it in. Yes, now it will turn off, on, off, on, off. Yes. Now turn that off. Turn that on, I mean. And connect another load on there. So I'll connect another load here. This is one for the oscilloscope. Yes, gonna have the oscilloscope in it. Yes, come on, turn on. Which one was for oscilloscope? Let me see. I think it was that one. Yes. That's on. I got a solder iron on as well. So these 2 are connected to that one, that's socket, and the light up there is connected to the other socket. So that one gets backup power, the other one doesn't get it. We'll turn off the main incoming, and under the time listen to that delay. So that will have a, I think it's 1 second or 1 second, 2 seconds delay, I think. Yes, remember this order, because it doesn't be like that when I turn it off. It's 3, 2, 1. No volts, no amps. Yes, little bit more than 1 amp. The light is still on. Switches are on. Yes, there's it changed the order. Inverter 1, inverter 2 is on. We have voltage out. The oscilloscope is off. The solder iron is off. Can test to turn on the... Yes. That's only the socket I have. I have another one here. Can have a big light connected to it. So you can see that it doesn't get any backup power. Yes, no light at all. Of course, you now may think that the switches are off, and of course they are. Let us find which one of them it was. I think it was that one. Yes, no light on it. So turn the RCD on and it will go on again. Yes, oscilloscope is alive. That one is alive. Voltage in, some amps, 1 amp, nearly 1 amp. That one is still on. Need to delete it. Yes, everything works. Oscilloscope works, now everything else. Yeah, so I'll turn it off again. Yes, everything works completely fine. 0 volts. Inverter is on, inverter 1 is on. Gotta turn it off. Yes, seriously how all this system works. Same thing with that Varec. That Varec turns off immediately when I have a power cut. So important thing to know is that you will never connect a vacuum cleaner or something else which have more than 1000 watts on that auxiliary socket, for that will may blow up the inverter if you get a power cut in exactly the same time you vacuum clean the room. Yes, of course, and all that wire on that side is connected to 24 pin sockets, multifunctional sockets, a 24 volt, 12 volt, 5 volt, lots of GND, yes, neutral, one phase, one other phase, phase 1, phase 2 I think, neutral, Varec voltage. Yes, this one doesn't have any, not so much functions. The other one, I have 2 of them. Yes, I'll turn on this one. Yes, that one there have more functions. That one gives out VFD as well. It's connected to the VFD, so I can run motors for various frequencies. But all the other things are the same. 24 volt, 5 volt, 12 volt come out of these wires. That one is a GND, 12 volt and 24 volt. I don't use 5 volt so much, but I have it there if it will if it will get needed someday. Let's turn the light off with the switch, turn the oscilloscope off, turn that off, turn main contactor off, turn inverter off, and screw out the battery's main fuses. Yes, that's a fast show what I have here. Electronic controls, something like that, and things like that. That's what I really like. Big fat cable. Lots of cables. From all the controlling side to the computer desk. Yes, thanks for watching.